It all begins with a dream, a vision of mobility, of trade, of speed. A highway is not just a road. It's an artery for the economy, a corridor for growth. In Kenya, where every kilometer counts, building a four-lane highway is no small feat. It's an intricate symphony of engineering, planning, politics, and persistence. Let's go deep, step by step, into how a four-lane highway is built in Kenya, from the first drawing to the final strip of paint. The journey starts long before a single shovel hits the ground. It begins with planning, strategic, national, and regional. Kenya's roads are guided by the National Transport Policy and Vision 2030. A four-lane highway project is selected based on economic importance, traffic studies, trade routes, or political commitments. It could connect cities like Nairobi and Mombasa, or unlock inland growth corridors. Once identified, a feasibility study is commissioned. Experts assess the terrain, forecast traffic loads, and estimate economic returns. Environmental and social impact assessments, ESEAs, are mandatory. Communities are consulted. Animals, forests, and water bodies are considered. Every stakeholder, from farmers to truck drivers, must be part of the equation. Then comes detailed engineering design. Surveyors and civil engineers take over, mapping every inch of the terrain. Soil tests are conducted to understand strength and stability. Drainage, topography, land slope, everything matters. The alignment is drawn, bridges and culverts planned, and materials selected. Now comes a major hurdle, land acquisition. Kenya's land ownership system is complex. Some areas are government-owned, others are private, ancestral, or even contested. Compensation must be fair, legal, and transparent. Landowners are compensated, structures relocated, and if needed, courts get involved. This step can delay projects for years, but skipping it causes even bigger problems later. Once land is secured, the project moves to procurement. The government, through KNHA or Kura, prepares tender documents. Contractors bid. Proposals are evaluated on cost, experience, and technical capacity. Corruption has been a concern in this phase, but recent reforms and donor oversight have improved transparency. After awarding the contract, the mobilization phase begins. Equipment is transported, labor is hired, and temporary site offices are established. Earthworks equipment, bulldozers, graders, compactors roll in. The transformation starts. First, clearing and grubbing removes vegetation and debris. Trees are felled, roots pulled, and the corridor is cleared. Archaeologists may be involved if anything historic is discovered underground. Next comes earthworks. This is where the raw shape of the road begins to form. Cut and fill operations level the terrain. High areas are cut down, low areas filled with soil and compacted. The subgrade, the lowest layer of the road, must be stable, dry, and strong. If not, imported materials are used to reinforce it. Then comes sub-base construction, the first structural layer above the subgrade. It distributes traffic loads and provides strength. In Kenya, this often uses natural gravel or lateritic soil mixed with stabilizers like cement or lime. Above the subbase lies the base course, a denser, stronger layer made of crushed rock or asphalt-treated material. It adds durability and handles the bulk of the pressure from traffic. Then comes the crown jewel, the pavement. For four-lane highways in Kenya, this is usually asphalt concrete. Hot mix asphalt is transported in insulated trucks and spread with pavers. It's immediately rolled with vibratory rollers to ensure smoothness and compaction. In some modern projects, Kenya uses rigid pavements, concrete slabs, in high-load areas like weighbridges or industrial corridors. But the road isn't finished yet. A highway needs drainage. Kenya's tropical rains can destroy roads if water isn't channeled correctly. Drainage ditches, culverts, side slopes, and longitudinal drains are installed. Retaining walls are built where terrain is steep. Bridges and overpasses are constructed where needed. Pile foundations are driven, piers built, decks cast. Special teams handle this phase, engineers trained in structural design and concrete technology. Some bridges take months to complete and require meticulous reinforcement and curing. Next, road furniture and safety features are added. Guardrails, rumble strips, cat eyes, lane markings, signage, speed bumps near interchanges, all help keep traffic orderly and safe. Overhead gantries are added in modern projects for digital signage and tolling systems. At this point, the road is almost ready, but one major challenge remains: utilities relocation. Power lines, fiber optic cables, water pipes, all must be rerouted. This often causes delays, especially if the infrastructure wasn't mapped properly beforehand. Now comes testing and commissioning. Engineers test the pavement thickness, strength, compaction, and surface smoothness. Drainage systems are checked. Traffic lights and signs are calibrated. Inspections are carried out by KenHA or independent firms. Once certified, the road is opened, often with ribbon cutting by politicians and excited communities. But the work isn't over. Maintenance plans are critical. Without proper upkeep, even a billion-shilling road can deteriorate in just a few rainy seasons. Highways require regular patching, crack sealing, cleaning drains, repainting lines, trimming vegetation, and occasionally overlaying new asphalt. Kenya's new roads often use performance-based contracts, where contractors are paid not just to build, but to maintain the road to a specific standard for 5 to 10 years. But there's more to these highways than asphalt and engineering. 4-lane roads in Kenya create economic transformation. They unlock land value, reduce travel time, enable regional trade, and connect farmers to markets. Towns along new highways often boom. Hotels, schools, petrol stations, and industries pop up, creating jobs and growth. There are also social challenges. Displacement, noise pollution, and increased traffic can hurt communities if not properly managed. That's why modern highway projects now include bypasses, noise barriers, pedestrian bridges, and even wildlife corridors in sensitive areas like Tsavo or the Mau Forest. Kenya is also integrating smart road technologies. Sensors embedded in roads monitor traffic and weather conditions. Weigh-in-motion systems detect overloaded trucks. Cameras monitor safety, and digital tolling systems reduce congestion at toll booths. Toll roads like the Nairobi Expressway are also part of the equation. These public-private partnerships accelerate road delivery, but come with controversy. Some argue tolls make roads elitist. Others say it's a small price for quality and speed. Ultimately, the future of 4-lane highways in Kenya is about balance between speed and safety, progress and preservation, expansion and equity. As more projects are launched, from the Mau Summit Highway to Lamu Corridor, it's clear, Kenya is not just building roads, it's building the future. From blueprint to bitumen, every step in highway construction reflects ambition, challenge, and resilience. The next time you cruise on a 4-lane road in Kenya, remember the decades of knowledge, effort, and courage that carved that road through earth and stone. Thanks for watching. If you learned something new, or if this deep dive into Kenyan infrastructure inspired you, hit that like button, subscribe for more, and share this with someone curious about how modern roads shape our world. Until next time, travel safe and stay curious.